Welcome to Brain Vision.
In this case, we were just asked to change the angle to 60 degrees instead of 30 degrees. So we're shortening the cables on the beam that come up to where they're attached. So there's a greater angle here. And really, that doesn't do anything to the shear forces in the beam, because the vertical components of those forces in the wire have to be the same. It's just the horizontal components that change because from this formula here, because theta changed. So we have different moments acting, and in this case we have a moment again in this region here. We have the functions here look pretty much the same, or close to the same. Here it's the same, and here it's the same. Here we have a little different, but basically it's just shifted. Instead of from here to here, we have this. And so because the point moments changed, because the horizontal loads in the wires changed, so we get a much greater jump, and we get much greater point moments. We jump all the way up from here to here. I forgot to label this point. But now what we can see is that here we still get to minus 0.675 kilonewton meters, but up here now, this point here is now 0.924 kilonewton meters, which is has greater magnitude than that. So now what we see is that our largest magnitude of our bending moment occurs at the middle of the beam instead of at the points where the wires were attached.